Alright guys, welcome to another video. We're going to start a new unit and we're going to be learning about some trig identities. And basically we're going to be looking at some relationship between, trig functions and stuff like that. We've learned a couple identities before, like Pythagorean identity. We're going to be talking more about those reciprocal identities. But today what I'm going to do is I'm going to teach you something called the sum and difference identities, all right? So I'm going to go ahead and write these relationships down just so we have them. But there's two I'm going to teach about, okay? And the first one you're going to be working on tomorrow is the sine. So basically, it goes something like this. So the sine of A plus B, and A and B would be angles there, right? The sine of A plus B. Well, you might say, well, don't I just distribute that? Well, that's not exactly how it works. Here's how it's going to go, okay? So the sine of A plus B would equal the sine of A times the cosine of B plus cosine of A times the sine of B. Okay, and I'll show you why we want to use this in a minute. And then the sine of A minus B would equal sine of A cosine B minus cosine of A times the sine of B. Okay, so that's what we call the sum and difference for the sine, right? You're just taking two angles, adding them. This is the relationship that exists. Same thing with this, okay? So while I'm here, I might as well just give you the cosines, okay? So same with the sine sum and difference, right? You also have a cosine sum and difference, so here's how it goes. Cosine of A plus B would equal cosine A times cosine B minus sine A times sine B. Now you'll notice there's a couple differences. You know how sine's mismatched, and that's this symbol, like the plus is right there. The cosines are kind of segregated. They have the cosines here, the sines here, and then if there's a plus, there's a minus in the middle, so it's kind of backwards, okay? But you could probably imagine how this is going to go. A minus B equals cosine A times cosine B plus sine A times sine B. So these are the formulas you're going to be using over the next couple days, okay? It's called the sum and difference formulas for sine and cosine. Okay, where A and B are angles. Okay, so go ahead and write those down. Get that clear out of the way so you can give this a good pause here. Boop. Okay. And so you might say, well, what do we need those for? Okay, well, here's what we are going to be doing. We're going to be working with proving identities later, or verifying them rather. We'll get into that later, but the first use we're going to have for these is I'm going to come to you. I'm going to say I want the sine of, I don't know, let's say 15 degrees. Okay. And you say, well, big deal. I'm going to type that in my calculator. I'm going to be done. I'm going to go to the next problem. Well, I'm going to take your calculator away. I'm going to say I want the sine of 15. I want the exact answer, okay? Well, you might panic a little bit because 15 is not one of the spots we memorize on a unit circle, okay? Let me show you a trick, okay? If you want the sine of 15, all you have to do is think about two angles that you can manipulate, add or subtract to get 15 that you know about, okay? So you might say, what are you talking about? Well, let me give you an example. Would you agree with this statement right here? The sine of 15 would be the same as the sine of 45 minus 30, right? Okay. Well, I'll tell you what. If we take this 45 minus 30 and we go back to our formulas and we expand it out, this would be our A, this would be our B, and it's a minus, right? So go back to that difference for a sine. It goes like this. It goes sine of A times the cosine of B minus the cosine of A times the sine of b, okay? And what we have there is we have some things we can easily deal with if you know your unit circle, okay? So let's think about this. Sine of 45, right? If you go to 45, you take the y value. That's root 2 over 2, right? Cosine 30, you go to 30, take the x value. It's root 3 over 2. Minus cosine of 45 would be root 2 over 2. Sine of 30 would be 1/2, right? If you multiply these two, root 2 times root 3 is root 6 over 2 times 2 is 4 minus root 2 over 4. And so what we can say here is this right here. Let me get, sorry. This would be the exact sine of 15. Root 6 minus root 2 over 4. And all we did was use the unit circle to come do that, right? So you might say, well, Mr. Wensler, 15 degrees, you said 45 minus 30 is 15 degrees, right? Well, what if I said that, let me change this. What if I said that, I don't know, 135 minus 120 is 15? Could I do that? Well, as long as that's 15, you can do it, and watch. This would be sine of A times cosine B. I'm just following the formula, right? Minus cosine A times the sine of B, like that. And if you went around and did this, look, the sine of 135 is this. The cosine of 120 degrees, let's think, that would be a negative 1/2, right? Minus cosine of 135 would be a negative root 2 over 2. And then the sine of 120 degrees would be root 3 over 2. Well, guess what? If I multiply these two, I get negative root 2 over 2 times 2 is 4, right? And here, look, that negative negative would kind of cancel out, right? And I would get that root 6 over 4, which would still go to, if you reverse these, it's still that root 6 minus root 2 over 4. That's the sine of 15 without a calculator. Isn't that cool that we can use this formula to come up with the exact value of sine 15 where we couldn't do that before, right? So that would be a valid quiz or test question. What's the sine of 15? Give me your calculator. This is what you would get. Now, as you're beginning, you could take the sine of 15 and get your decimal, right? And then you could practice this and say, okay, well, if I took root 6 minus root 2, hit enter, and then divide that by 4, do I get that same decimal? And you should, okay? So that's how we can use the sum and difference to find these values, all right? So let's look at another one real quick. What have I said? I don't know. What have I said? I want, let's say the cosine of negative 15 degrees, something like that. Okay. Cosine negative 15. Okay. Well, how would I get a negative 15? What would I need to add or subtract to get a negative 15? Well, you could do something. I mean, there's no wrong way to do this, but the thing you want to think about is you want two angles that get you that you know about from the unit circle, right? So I'm just going to use that 30, 45 again. So what if I said like 30 degrees minus 45 degrees? Well, that is in fact negative 15, right? So all I got to do is go to my formula and expand this out. So the way this works, cosine of 30 minus 45, right? That would be cosine A times cosine B, remember it's the opposite, plus sine A times the sine of B, right? And if I do that, just expand this out, cosine of 30, you go to 30, take the x value, that's root 3 over 2, times cosine of 45 would be root 2 over 2, plus the sine of 30 degrees, that would be a half. And the sine of 45 would be root 2 over 2. So you get root 6 over 4 plus, this would be root 2 over 4, which would be root 6 plus root 2 over 4. you'll notice that a lot of these look very similar, right? Lots of root 6s, lots of root 2s, lots of 4s because of the way that these ratios worked out on the unit circle, right? But this would be the exact value of cosine negative 15. Well, you say, Mr. Winslow, it's cosine negative 15. How'd you get a positive answer? Well, remember, negative 15 would be right here, which would still have a positive x value, right? So that's why the cosine would still be positive, okay? So, pretty easy stuff, right? All you have to do is think about the angle in terms of angles you know about, okay? So, let's do one more here. Watch this. Let's say I did, let's say I did the cosine of 5 pi over 12, and I want to know what's cosine of 5 pi over 12. You might be thinking to yourself, crap, I don't know about 5 pi over 12, right? I don't know the unit circle. Well, anytime I get one on radians for one of these, I automatically just smile and nod, and I go over here, and I do this, right? Now, if you look at this, what am I doing here? Well, I am essentially turning this into degrees because you'll get the same answer. It's just easier to think about it in terms of degrees, right? So if the pi's cancel out, right? 12 goes into 180. That's 15 times, and 5 times 15 would be 75 degrees. So basically, we got the cosine of 75 degrees, right? I promise I won't tell anybody that you did that because you'll still get the same answer, right? But cosine 75 degrees, let's just think about it. We want, let's just say, I don't know, you could do this, it's kind of boring old same stuff, but cosine 30 plus 45, right? Well, if you expand that out, it's just cosine A times cosine B minus sine A times sine B, right? Let me read, hold on. Let me give myself some more room. I apologize. Excuse me 1 second. So you just say, hold on, cosine A times cosine B, just following the formula, minus sine A times sine B, and I just go through and find those things. So the cosine of 30, go to 30, take the x, that's root 3 over 2. That's root 2 over 2 minus the sine of 30 would be 1/2, and the sine of 45 would be root 2 over 2. And so you would get right here, this would be root 6 over 4, right? Minus this would be root 2 over 4, which would end up being, surprise, surprise, root 6 minus root 2 over 4. That would be the exact cosine of 75 degrees. So that's essentially what you're going to be doing over the next few days. You're going to be taking angles that you wouldn't normally know about, but putting them in terms of angles you do know about, and just expanding those formulas out. The first ones I had, right? Expand those formulas out to get, to get your exact answers, okay? So this would be a definite non-calculated portion of an assessment, okay? Because, we don't need a calculator to do this, all right? So my only advice is if you get it in radians, just put it in degrees, and you should be good to go. So once again, watch this. Sine of, I don't know, I'll call it x plus y this time, right? Sine x cosine y plus cosine x sine y. Okay? You could even, watch, I could write, check it out. I could write both these formulas once. Plus minus, plus minus. That means the plus goes with the plus, the minus goes with the minus. Well, guess what? Cosine x plus minus y, right, would equal cosine x times cosine y, right? Then over here, you have sine x times sine y, right? And instead of plus minus, you actually have minus plus, because when it's plus, it's minus, and when it's minus, it's plus, okay? So, I always think about this. It's kind of a weird way to think about it, but segregationists are kind of backwards people, right? You don't want to be segregated. So the cosine's kind of segregating, and their signs are backwards. So it's kind of a weird thing to think about, but that's kind of how I remember it. And the signs, they mix nicely, they play nicely, so the signs go nicely as well. Okay, so anyway, I hope that helps. But that is your sum and difference identities for sine and cosine. Okay. Hope this video finds you well. Like I said, I'll be back sooner than later. And shout out to all the people complaining about these videos that aren't actually watching them. I hope your grade goes up soon through wishing it so. Okay. So see you guys soon, and have a good one.